Today we're going to talk about quadratic functions and transformations. So a quadratic function is a nonlinear function. It can be written in two forms. Standard form, which we're going to talk about at a different time, but I'm just introducing that now. So standard form is y equals ax squared plus bx plus c, where a cannot equal 0. And the reason a cannot equal 0, if this a equaled 0, there would be no more x squared, right? This whole term would cancel out. If x squared canceled out, it would no longer be a quadratic function. So that's why a can never equal 0. Okay, and then vertex form, which we're going to look at today, is y equals a times the quantity x minus h squared plus k. And again, a cannot equal 0 because then this whole thing would cancel if a was 0, and then it would no longer be a quadratic function. Okay, so the U-shaped graph of a quadratic function is called a parabola. So this is what a parabola looks like. And this is on the left, it says the parabola on the left is called the parent quadratic function. The parent quadratic function is f of x equals x squared. Okay, so that's the parent function of a quadratic equation. And a parent function is just the simplest form in the family of functions. So for example, can we get any simpler for a quadratic than f of x equals x squared? No, we couldn't get any simpler than that in a quadratic. That is the simplest form, and that's called the parent function. Okay, so I just labeled that graph f of x equals x squared. So the graph of all other quadratic functions are transformations, and we're going to be talking about transformations. So this is the simplest form right here, this graph, that is the simplest form. But we could have it move up, we could have it move down, to the left, to the right, we could have it get wider, we could have it get skinnier. So that's the simplest form, but many things can happen to that parabola, to that quadratic function, and that's called a transformation. So other characteristics, the lowest or the highest point on a parabola is called the vertex. So the lowest would be the minimum, right? The highest would be the maximum. In this case, our vertex has a minimum at 0, 0, right? It's the smallest point on that parabola, and that's at 0, 0. Okay, the vertical line that divides the parabola into two symmetric parts is the axis of symmetry. Okay, so if we look the axis of symmetry, we always label it with a dotted line, just like you see on that picture. The axis of symmetry in this case is x equals 0. So I know I'm just throwing a lot of new things your way, but this is just a summary. It's going to make more sense as we go on. All we really talked about so far, vertex form, but we're going to get into that on the next couple slides. So the biggest thing right now, axis of symmetry, it just divides this in half right here. Just divides the parabola in half. Okay, vertex, which we just said was 0, 0. Okay, that piece, that piece is 0, 0. Okay, right there in the middle. And that's the vertex. And that's either the lowest or highest point on the graph. And this is called our parent function, which is just the simplest function for a quadratic. Okay. All right, so let's look at an example. So identify the vertex, axis of symmetry, which I'm going to label AOS from now on. It's just easier. And then domain and range. Okay, so we're going to look at this picture, this example right here. Remember, the vertex is the lowest point or the highest point. In this case, whenever our function opens, whenever our parabola is like a U shape, we're going to have a minimum or a lowest point, right? So right there, that's where our vertex is going to be. So that point, we're going to go over -2, and we're going to go down -3. So that point is -2, 3. Okay. -2, oh, sorry, excuse me, -2, -3. Okay. So axis of symmetry. Axis of symmetry is a line that divides the graph in half. So that piece right there. And it's going to be x equals, always write it as a line. It's not a point. It's not just -2. It's x equals -2. It's that whole line right here. This whole line is x equals -2. And then domain. So my smallest x value, remember see this arrow right here on both sides? It's going to go on forever in this x direction, forever both directions because of those arrows. So my domain is -infinity to infinity. It never stops in both directions, goes on forever. My range, is there a smallest y? Well, yes, in this case there is. See how this point right here, that's the smallest y value, right? There's nothing lower, there's nothing down here. There's nothing lower than that y. So in this case, my range is going to start at -3, and it's going to go up to infinity. Remember, we use a bracket because that point is included. Unless we see an open circle, it's always a bracket for the number, okay? And always parentheses for infinity because we never include infinity. That's not a real number. Okay, so recall one of the forms. So remember I said we're not going to talk about standard form today, but we're going to talk about vertex form. So vertex form is y equals a times the quantity x minus h squared plus k. Now your vertex here, your vertex, remember that lowest or highest point on your parabola is your vertex. Vertex is h, comma k. So that's your vertex. We can easily pull out, if I asked you what is a vertex in this case, and there are numbers replaced for h and k, you easily can pull out those two numbers. Okay? Notice that this that minus sign is part of the formula, which means when we pull out our h, it's going to be the opposite. So see how it says x minus h? But notice a negative h didn't come out, a positive h came out for the vertex. So it's actually going to be, if it's, let's just say it was x minus 2, when we pull out the 2, it's going to be a positive. If it was x plus 2, when we pull out the 2, it's going to be a negative for the vertex, a -2. Okay, and we'll talk more about that. Okay, the axis of symmetry, remember we always said it was x equals, we want to write it as a line, x equals h. So in this case, whatever your h is right here, that's going to be your axis of symmetry. X equals that number. Okay, and then it's either going to stretch or compress if a does not equal 1. So if that equals 1, nothing happens. It does not stretch or compress. But if it does not equal 1, less than 1 or greater than 1, it does stretch or compress. And we're going to talk about if it's stretch or compress. That's a transformation, and we're going to talk about that next. Okay, so summary of transformations. So let's talk about first f of x equals x squared. This is the same thing as y equals x squared. That f of x is the same thing as y equals. So f of x equals y equals. It's just a different form. It's a different way of writing it. It just says a function of x, f of x equals x squared. Same thing. So do not get confused with that f of x. You can replace it with y and it's the same thing. Okay? So remember we said f of x equals x squared or y equals x squared. That's our parent function. And remember, a parent function is the simplest form. So we cannot get any simpler than y equals x squared. That's called a parent function. Okay? So let's first talk about a vertical translation. So vertical, remember, is either up or down, right? That's vertical. So when we're talking about a vertical translation, here, when x squared, when our parent function, remember this piece right here is our parent function, right? F of x equals x squared. That's what it says up there. F of x equals x squared. That's our parent function. When it gets added k, some kind of number, so it could be like x squared, let me get a different color. If we had something like x squared plus 3, okay? That means the f of x, x squared, the parent function, is translated up k units or up 3 units. Just like that picture that you see right here. Okay, so that shows how our graph, our parent function, would be translated, be up 3, for example. That's just an example. Here, f of x equals x squared minus k. In the same way, f of x equals x squared, our parent function, is translated down however many units, so k units in this case. So it would look something like this. So notice here, it's going up, and here it actually moved down from the origin. Okay, let's talk about horizontal translation. So horizontal means we're going to be moving either left or right, right? So notice vertical translation, we either moved up here or we moved down here, okay? So horizontal is going to be either left or right. So f of x equals x squared. That's our parent function, right? When it says x plus h squared, when we're adding something on the inside of these parentheses like that, and then we're squaring it, rather than just having that x squared by itself, when we're adding something in the parentheses, it's actually going to be translated left that many units. So here is where we started. We would start with maybe something like this, the parent function, right? Notice it went left however many units. So if it went left 3 units, 4 units, 5 units, however many units, it tells you right here. The h tells you how many units. Okay. Now f of x equals x minus h squared. F of x equals x squared. Again, this is the parent function, and it's translated right however many units. So this h will tell you how many units this is moving to the right. Okay. And we're going to have practice with some examples after we finish these, but let's just talk about reflection. So reflection, if f of x equals, and then in parentheses, negative x and then squared, this is a reflection over the y-axis, okay? If the negative is outside of the parentheses, there's no parentheses here, right? It's just negative x squared. It's going to reflect over the x-axis, okay? If a is negative, reflect. So in this equation right here, if that number is negative, if there's a negative right here, like this outside, okay, if there's a negative outside of that a, then that means we're going to reflect. So instead of looking like this, like our normal parent function, our normal y equals x squared, it's going to be flipped over to the other side. So whenever you see a negative in front of this a term, whenever you see a negative there, you're going to flip that over. It's going to reflect over the x-axis. Okay? And last piece before we move on to some examples, stretch or compress. So we're looking at the a term here. We're looking at this term here to see if our graph stretches or compresses. And our function, if it's just a 1, so if it's just f of x equals x squared, and this number is just a 1, it doesn't do anything. It's just normal. But if it's greater than 1, it's going to stretch. And you would kind of think it would get wider, right? That's what you would think stretch means. But actually, stretching is going to get skinnier. So the graph's going to get skinnier. So notice this graph right here. It looks skinnier than the normal graph maybe that you see that we drew for the parent function. So it gets skinnier, okay? That's if the number is greater than 1. So maybe an example would be 3x squared, right? Now notice these absolute value bars. That means if it was a negative 3x squared, absolute value of that a term of that negative 3, the absolute value of negative 3 is 3, right? So 3 is greater than 1. So don't worry about that negative sign. Remember that negative sign doesn't tell us if it stretches or compresses. This negative sign, remember, negative sign tells us if it reflects. All right? So if a is in between 0 and 1, then it compresses and it actually gets fatter. Okay, the graph gets fatter. So maybe something like that. So pretty much this whole thing says if a is in between 0 and 1. That's the same thing. So if a is in between 0 and 1, that's what this piece means. That just says if a is in between 0 and 1. So maybe 1/2, 3/4, 2/3, right? All of those numbers are fractions in between 0 and 1. And if it's in between, it means your graph's going to get fatter like that. Okay, so let's put some of these with examples so you can kind of see how this all works, okay? So f of x equals x squared equals x minus 2 squared plus 3. So this is the first example. So we're going to kind of see how this transforms. So let's look first at this -2. Remember when it's inside the parentheses. If we go back to the last page and we were to look here, it's inside the parentheses, right? X minus h squared. Remember, it's going to be translated right. Okay? So in this case, when we go back here, this is x minus h, right? It's -2 this time though. So it's going to be translated right 2 units. That's all that means. Now that plus 3 is like saying plus k. Okay, so we're going to be looking, I'm going to write the vertex form actually right here. Y equals a times x minus h squared plus k. So notice this is like the h term. The h term here is 2. And then this outside of the parentheses, that's our k term. Okay? So our k term is 3. Well, it says that when it's a positive 3, it's translated up 3 units. And that's it. That's how you'd write that. Translated right 2 units and translated up 3 units. Okay? So the original function, the parent function, f of x equals x squared, this function, is translated right 2 units and translated up 3 units from this equation. Okay, that's what it tells you. All right, so let's try this next one. So f of x equals 3 times the quantity of x minus 2 squared. So first we're going to look on the outside. That 3, remember, is our a right here, this a. There's an a this time outside. So we're going to look if it's greater than 1 or in between 0 and 1. In this case, it's not a fraction. It's actually greater than 1. So when our a is greater than 1, okay, 3, the absolute value of 3 is greater than 1, it's going to stretch by a factor of 3. So look back in your notes. Take a look at how we found that. Okay, so it's going to stretch by a factor of 3. The next one, minus 2 squared. So remember, when it's minus 2, we're translating right 2 units. So take a look back at your notes and see how I'm getting this so that it makes sense. Okay, take a look at how translations work. Okay. Let's try another example. So here we have quite a few things. We have a negative, we have a 1/2, and we have a -7 at the end. So those are the 3 things that are different, that are transformations from the original f of x equals x squared. Okay, so let's take a look at the negative first. So remember, when we have a negative outside, that means reflect over the x-axis. Whenever we have a negative number in front of this a term, that means reflect over the x-axis. Okay, now this 1/2. Well, this 1/2, is that in between 0 and 1? Or is it greater than 1? It's in between 0 and 1, right? So, and remember, even though that negative is out there, it's still positive 1/2. We're not looking at that negative, means reflect. That has nothing to do with this a term, with this fraction, okay? So a, that 1/2, is that greater than 1? No, it's not greater than 1. It's actually in between 0 and 1, right? It's less than 1. It's in between. I'm going to write this. It's in between 0 and 1, right? So this means compress by a factor of 1/2. Remember, if it's in between 0 and 1, it's compress, not stretch. Okay, and the last piece of this, that -7, means translate down 7 units. Translate down 7 units, okay? All right, last one. So, ignore this. That was from the last example. Okay, f of x equals negative x plus 7 squared minus 1. So notice this negative. That's the first thing we're going to be looking at. That negative means reflect over the x-axis. Again, it's outside of the parentheses, just like this one had no parentheses around it, right? This one it was just outside of the parentheses. There's not even parentheses there. So that means reflect over the x-axis. In the same way, this means reflect over the x-axis. Okay. All right. Now this piece, that's 7. Remember, inside, if it's a 7 and it's a positive right there, that positive 7, you always want to think the opposite. So we're actually going to go left 7 units. Left 7 units. So we always want to think the opposite of that plus. Okay? And that -1 means translated 1 unit down. So quick overview. When we have y equals a times x minus h squared plus k, this piece means you're either going left or right, just depending on what your h is, depending on the negative or positive sign. This means you're going up or down. Okay, that's what that k tells you, that the function is going up or down. And this a tells you stretch or compress. If it's not 1, it's either stretching or compressing. And then if you have a negative sign out here, so if there is a negative, if it's positive, it's going to look like this, right? But if it's negative, this tells you reflect over the x-axis, which just means it's going to be going like this now. Okay?